sometimes when you're working a problem, you need formulas to work other formulas. That's how even a really small problem like this one can result in a lot of scratch work, in essence. Now, what do I mean by you need formulas to work other formulas? Let's take a look at this. A carpet cleaning firm uses an average of 20 gallons of cleaning fluid a day. Okay. Important fact. Usage tends to be normally distributed with a standard deviation of 2 gallons a day. Lead time is 4 days and the desired service level is 92%. What's the question? What is the most appropriate reorder point for this carpet cleaning firm? Now, first off, setting a reorder point. That's a formula. Let me think, what is that formula? Well, setting a reorder point is all about the distribution of demand during lead time, because your most appropriate reorder point should be your average demand during lead time plus some appropriate z-value times the standard deviation of demand during lead time. So I'll set those off in a parentheses. And, you look at that and say, okay, yeah, well, I see that there was some about a standard deviation of 2, so, at least that goes there. And an average demand rate of 20. No. 20 doesn't go here, 2 doesn't go here. Because setting a reorder point is all about demand during lead time. Now, it helps me to draw a picture. Demand during lead time is assumed here to be normally distributed. So it will have a certain average and a certain standard deviation. We're trying to set the reorder point. Now, we were given a hint about where to set the reorder point. The hint had to do with the service level. When you set a reorder point, this distribution is meant to represent every possible amount of demand during lead time that might happen, and then the height of the curve over any one point, remember these are numbers here, represents the likelihood of like that particular level of demand. Okay, so if you're going to reorder at a certain point, the area of the curve to the left of that point represents all of the possible outcomes in which actual demand during lead time was less than the reorder point, and that's perfect because that means that we had enough, right? That the amount that we left in stock when we reordered lasted us in essence while we waited for the new shipment. What's more kind of troublesome is that little itty bitty part of the normal distribution that's to the right of the reorder point. That's our stock out risk, because those are all outcomes that are greater than the reorder point, and their combined area represents the likelihood that there would be demand in excess of the reorder point during lead time, and that's where we're stuck. We don't have enough. We run out. Now I said that there was a hint here as to where we should set for this problem the reorder point. Yeah, what I colored here in yellow ink, that is also known as the service level. That is what the service level looks like. Service level, the probability that demand will not exceed supply during lead time, the probability that you'll actually have enough, that's what it looks like. It's right in here. That, by the way, we don't need it for this problem, but that other little part is the stock out risk. And we were told the service level. It says a desired service level of 92%. That means that if we set this reorder point in the proper place, 92% of the curve should be in yellow. It should be to the left, right? And then 8%. The stock out risk is 8%. Okay, fine. Now, still, we have this one formula here. Actually, that part of it, the 92%, that would help me find Z. Right. In order to track down what Z I should be using, I want to get a Z table, which shows me the area of the curve to the left of something I'm interested in, like the reorder point. I'm looking for a z-value that happens to trap 92% of the curve to the left of the reorder point. That is to say, this is an example of using the z-table backwards. I want to find the number that is closest to 0.92 here inside the table, in the body of the table. Okay, 0.92. 0.92, I don't think we're going to find it exactly. 0.9192 is pretty close, and then it goes to 0.9207. It's pretty close between these two, but actually this one is closer to 0.92. You say, all right, well that's as close as we can find to 0.92, that right there on the z-table. You say, yeah, okay, now what do I do with that? Oh, we found for our formula the z, because we want to know what z that corresponds to. So here's the area, right? We're using the z-table backwards. Trace the row number 1.4, that's the first two digits of the z-value. And then ask yourself, well, what column am I in? Well, I'm right there in the far left-hand column, that's 0. Oh, so the z value that corresponds to 92% of the curve being to the left of something that you're interested in is z equals 1.40. Oh, all right. Found this part right here. 1.40. But I had said, whoa, no, don't put a 2 here or don't put a 20 here, because we actually need some other formulas. Now wait a minute, we were given information about demand during lead time. It says that the carpet cleaning firm uses an average of 20 gallons a day. Okay, mu for average, but D for day. Daily demand, the average is 20 gallons, and a standard deviation of 2 gallons. The standard deviation in daily demand is 2. That is not the same thing as the average demand during lead time. Oh yeah, because think about it. We're told here that lead time is, you know, and you say, well, I don't see where I'm supposed to put it in the formula, but it's important. Lead time is 4 days. So let's think about it. Lead time is 4 days. On average, you use 20 gallons a day. Therefore, on average, what do you think that you would use during lead time? Well, 4 days at an average of 20 gallons a day. That's 80 gallons? Yes. Yes. Okay, so average demand during lead time. Oh, well, wait. You can reason through it this way, but maybe we should be more formal about it. This particular situation, we have information about lead time, but we don't have information specifically on demand during lead time. All right, so formally, an important step here is to recognize what kind of situation we're in. Demand during lead time varies, but why? Okay, in this case, it varies because there is variable demand, daily demand, but a constant lead time. Variable daily demand. We don't know exactly how much will be needed each day, but in this particular instance, there is a constant lead time. That doesn't vary. It just said 4 days. So the source, see, this is what's important. The source of our uncertainty as to exactly how much we're going to need during lead time is because demand varies each day, not because the lead time varies in length. You say, well, all right, why is that important? Because that tells you what sub-formulas to use to find the average demand during lead time and the standard deviation in demand during lead time. All right, based on the fact that this is a variable demand constant lead time case, your average demand during lead time, we were just reasoning through that. That's actually pretty intuitive. What you do is you say, well, it's average daily demand times the length of the lead time. I mean, you use on average 20 a day times, there's 4 days. Yeah, it's 80. The center of this curve here for us is 80. Now, wait. You might be thinking, okay, fine. Now I need, for right here in the formula, the standard deviation in demand during lead time. So what I should do is take the standard deviation in daily demand and multiply it by the lead time. No, whoa, no, not quite. Okay, in the variable demand constant lead time case, the standard deviation in demand during lead time is determined by, now you're right, you do use the standard deviation in daily demand, you multiply that times the square root of lead time. You have to remember that it's the square root of lead time. So what you have now is 2 times the square root of 4, or 2 times 2, or 4. That's the number that we use for our formula. To set the reorder point going all the way up to the top, we would say 80, right? We found that out, plus 1.4 times 4. Now I'm filling out the formula finally that we started with. Okay, 80 plus 1.4, that z-value we got from the table, times the 4, which we got from that other formula. That's where we get 85.6. I mean, that's what I get on my calculator when I fill that out. That's the reorder point. Reorder when you have 85.6 gallons of that cleaning fluid left in stock. Why? Because 92% of the time that will last you till the new order gets there. Okay, 8% of the time you are going to run out, but what they asked for was a service level of 92%, so the reorder point should be 85.6.